Hello, everyone. Wow, a lot of good friends here today. Lars from nanoplus, long time no see. And also new friends, Bill from nanoLambda. You have great technology. I'm really excited that you're here today. My good friend César from Spain, from smartHAPS. You're going to be amazed what these guys can do and what these guys can help us do. Let's get the ball rolling. Ladies and gentlemen, welcome to the epic online meeting on environmental monitoring. 2020 is a year we will never forget, but every year, over 1.6 million people die in the world as a result of air pollution. There are treaties between governments to drastically reduce emissions. But how about the compliance check? How do we know at every location and time what is the concentration of NOx, CO, or CO2? This is where Photonics comes in. In the last year, we have developed technologies to monitor any chemical compound that can absorb a wavelength between the visible to the mid-infrared. Let's bring together all the main players, from the companies developing the technology all the way to the companies who can deploy that technology at key specific locations on Earth, on the air, and on space. So join us Monday, 15th of June, 3 p.m. Central European Time, the epic online technology meeting on environmental monitoring. Let's take a deep breath. Let's take a deep breath, everyone, and let's start what is going to be one more epic meeting. The purpose of this meeting for all of you is to make connections. So after this meeting, what we really want is that you start doing the follow-up. After the meeting, what we will say is the ball is in your court. We just want to establish new collaborations. And for that, I just have a couple of things to tell you for you to understand a little bit what is really happening here. So first of all, what is really happening here, we have a very outstanding co-chairperson, Ana Gonzalez, who has been going all around the world in the last 4 years, scouting every single company that has something to do in gas sensing and environmental monitoring. And thanks to her work, we have been actually bringing many of you today here. Today is the number 27 of the EPIC Online Technology Meetings. We started on 1st of April with femtosecond lasers. Nobody would have told us, or at least we wouldn't believe them, if they told us the success that these meetings were going to create in the industry. Actually, I have to say that these meetings have been live streaming YouTube, and afterwards we have already something like 30,000 views in total, views of the videos that have been posted in LinkedIn out of these meetings. So it's getting a lot of impact. We're getting lots of comments. Most important, we're getting a lot of companies engaging with EPIC. EPIC has now 569 members of EPIC. I think we can reach 600 by the time that is our last EPIC Online Technology meeting on the 15th of July. And thanks to your support, we are doing completely crazy things, very, very crazy things. Actually, you should know that on the 24th of June, I'm going to chair a meeting for 24 hours straight. I know that sounds completely crazy. It is. It was Carlos' idea, and my doctor doesn't like him. And I also would like to thank many of you sending me lots of toys and gadgets and coffee. And even Photonics sent me like a really beautiful toy that my daughter loves. I love the support. I'm going to be amazed with 24 hours of Photonics. I'm going to learn a lot, and I hope I will survive. The world is going back to normal little by little. Well, the new normal, they call it. So we are very excited to say that we are going full speed with our events in Q4. We have a really fantastic meeting being prepared at HBM Fiber Sensing on fiber sensors, and a really truly amazing meeting on medical devices at Philips. So if you are interested in any of the upcoming present meetings or any of the upcoming online meetings, or you just want to talk to Anna because she's fantastic, send us an email and we'll be happy to assist you. And we keep assisting you because we keep buying market reports, and I would like to let you know, well, all of you are members, so just remember that you have access to a long list of market reports. They are there for you. But I read them as well, not only buy them, I also read them. And I read the market report that we bought on the laser forecast 2020-2025 from Strategies Unlimited. This is the most expensive market report we have bought lately. We bought it 2 weeks ago. And there's a whole chapter 11, on the forecast of lasers for spectroscopy. And believe me, you should have a look at it, especially on the solid state lasers, on the diode pump SSLs. There is quite a huge growth looked up for environmental monitoring in the ultra-fast laser segment. Have a look at this chapter 11. It's actually worth it a reading. We have the biggest website in finding a job in photonics right now, www.jobsinphotonics.com. So we have scouted actively the job openings of all the members and we put them in the website. So if anybody is looking for a job in the YouTube universe, if you're looking for a job, look no further, jobsinphotonics.com. And with this, let's go to the topic of interest today, the topic of online technology meeting on environmental monitoring. First of all, I would like to thank our sponsors today, Axetris. Axetris is the company that makes fantastic micro-optics, also fantastic thermal sources, and they also assemble their own instruments, making even OEM modules for gas sensing and other applications. In Switzerland, a great company, Ocean Insight. From the technology of Ocean Optics, manufacturing spectrometers, miniaturized spectrometers, and high-end spectrometers for gas sensing and other applications, focusing mostly on the OEM business, solving any kind of challenge you have in spectrometry for gas sensing. Technobis, all the way from the Netherlands, a company specialized in doing photonic integrated circuits for interrogators of fiber sensors, but at the same time also specialized in packaging peaks for any company in the world using the equipment that we are very proud of having in Europe for the volume production of integrated photonics. VIGO Systems, all the way from Warsaw in Poland, making fantastic mid-IR detectors. We all love the mid-IR detectors, but the material is getting so good, they're actually offering material for other applications. And 3 weeks ago, they manufactured the first ever VCSEL in the mid-infrared. Fantastic company. And also from Germany, nanoplus. I just love nanoplus. Any laser from any wavelength, from the visible all the way to the long infrared, these guys can actually make integrated laser solutions that can actually solve the OEM market all the way to the consumer market. Thank you, nanoplus, for being a member of EPIC. And that's all I had to say, because now I want to give the floor to my perfect co-chair today, Ana Gonzalez. Ana, thank you very much for being with us. What's in the menu today?
Thank you very much, Jose, for this nice introduction. So yes, I'm very happy because I think we have a very interesting meeting ahead. And well, environmental monitoring is one of my favorite topics, save the world. So here we have an impressive list of speakers to trigger the discussion. But these are not the only companies that are involved in the meeting this afternoon. We have a representation of the entire supply chain, because what we want is to make collaborations, new collaborations, to push new technologies. And for that, we need companies in all the levels. So we have the end users, and we are going to ask them what they need. For them, we have the companies doing integrated sensors and also spectrometers and also system integrators. So we have, for example, for as system integrators, we have Axetris, Tenevia, Kerr sensors. As spectrometers, we have Avantes, NLIR, Lambda X, Ipsen, Photonics. So for them, it's like, what do you need? Do you need micro optics? Do you need new cameras? And for this, we have the other levels. So we have companies developing IR detectors of cameras, such as Photonics Sensor or Hamamatsu or Sumitomo Electric. But we have also companies doing optics, filters, squatting, like Viavi, Oplatec, or 26. And also other companies in other levels, such as for developing big wafers or thermals, IR emitters of ultra-fast lasers, and also companies doing IR lasers. Also, thank you to Proambiente, is another association to join today. And also here we are collaborating with the pilot lines in photonics, such as MIRFAB, that is for prototyping and going to larger volumes for mid-infrared-based chemical sensors. Also, we have a PIXAP for the packaging and assembly of photonic integrated circuits, also working with the standards along the entire supply chain and for going to large volumes. And also we have Fabulous for freeform micro optics, also for going to large volumes. So I think that's it. Do you have anything to add, Jose?
Never, because you always give such a complete story. I would like to tell everyone who keeps telling me, Jose, you forgot our logo. I never forget any logo, any of these 570 companies. I never forget their logo. These are only, in this slide, you can see only the companies who register for the fantastic meeting today. A meeting that is also live streaming YouTube. So hello, YouTubers from all over the world. See you soon in 24 hours straight. if you want to contact any of the speakers or participants at the meeting today, all you have to do is send me an email, jose.pozo@epic-asoc.com. That's valid for the YouTubers as well as the people participating in the Zoom channel today. All you have to do is send me an email, jose.pozo@epic-asoc.com, and I will make that introduction only because I really love doing that. I really love introducing people, as well as I love when people do business thanks to an epic meeting. And that's what we are going to do today. Let's get the ball rolling. Anna, are you ready? Is Anna ready? Anna looks ready, right? Let's start. And let's start with Italy. Let's start with Proambiente, their first ever epic event for them. Thank you, Ivan. Grazie mille for being with us today. The floor and the attention of everyone here and in YouTube is yours.
Okay, Jose, thank you very much. I'm here because we met last year in June in Munich. We have exchanged a few words, and now the first result is this. I'm now here to present very shortly our activity. I don't just a minute. I have shared my screen. Just a minute. Okay.
The magic of traveling. I actually met many of you in conferences. Actually, many of you I met in a conference in Barcelona at the Smart Cities conference last November.
Do you see my screen now?
Crystal clear. The floor is yours.
So, well, I'm Ivan Kostadinov. I'm researching at Proambiente. Proambiente is a private public consortium which is located in north part of Italy in Emilia-Romagna region. And Proambiente is a part of a high technology network of this region. Actually, Proambiente is a private public consortium with 11 small and medium enterprises with head offices in Emilia-Romagna region. And public part is represented by National Research Council, that is the largest public research institution in Italy, and the University of Ferrara. Our mission is oriented towards the technology transfer of the research products generated in the research institutes regarding large issues of the sustainable development. For instance, atmospheric pollutions and air quality, aquatic environments, treatment of wastewater, precise agriculture. All this our activity is shaped within the different national or international projects. And you can see here in the middle the growing number of the projects where we are working on. Our team is composed with several electronic engineers, computer scientists, marine geologists, physicists, chemists, agronomes, environment scientists. Our activity regards the development and implementation of innovative methods and systems aimed to bring the ideas from lower technology readiness level to higher technology readiness level and to pass the products to the industry. So in other things, we are bearing between the research and the industry. For this, our activity, you rely on the modern laboratories equipment, which are inside of Proambiente or the CNR. Here we can see a few photos. That is the Bologna research area where the building of Proambiente is located, and two pictures of one of our laboratories for optical spectral measurements. Okay, now I will shortly mention two of our activities which regards the environment monitoring. We have developed a 3-wavelength mini LIDAR for 3D stack plumb reconstruction and atmospheric backscattered profiling. This LIDAR is mobile equipment. It's easy to install in a van and transported in different locations. Two examples here, we can see on the left one probing of the atmosphere, and the second one measurements at about 500 meters from the industrial stack in order to evaluate the plumb, the stack plumb in 3 dimensions space in order to provide information useful for the dispersion models. Okay, this LIDAR operates at 355 nanometers, 530 to 1064 nanometers, And green channel is split it in two sub-channels, that is polarized, depolarized one. Okay, now we need to update this laser because the digitizer is, let's say, a little bit obsolete. So we, knowing that nowadays there exists more advanced solution, we would like to improve its performances. Well, another device that we have developed here, it is acoustic-optical spectral hyperspectral imager. It is aimed to measure the spatial distribution of nitrogen dioxide over extended area, implementing differential optical absorption spectroscopy. The device implements two paratellurite crystal cells. It with exploring 390 to 600 nanometers with resolution, spectral resolution better than 2.2 nanometers. The device consists also the cooled camera, CCD camera with very low dark current. And we have used this device also not only for the atmospheric monitoring, that I can have to be in my honesty, there is a lot of work to do else in this regard, but we have used the device also for the some studies for the crop's health, from the state of the fruit maturity, the length characterization, and culture heritage. And there on the next slide, we can see another activities of our laboratory, which regards the development of a smart station for the indoor air quality and comfort. Informare, that is a project within which we have been developed multi-platform tool for to the tourism industry, providing extremely useful information for the tourists. We have operated also on development of an innovative device for it is aimed for measurement of the polycyclic aromatic hydrocarbons. Another activity regards the realization, development, and construction of aquatic drone for marine and lagoon ecosystem monitoring, integrated monitoring. Let's say only to mention in advance that now we are working also on the development of hyperspectral microscope for the public health, for the lipidomic analysis and the red blood cells membrane. Well, it is very shortly. I don't know if I stay in this 6 minutes, but it is only to a few points in order to let you know the fields where our activities focus it on. If you would like more details, please contact me at my email or visit webpage of Consortium Proambiente. I have prepared also one slide, not 3, but 4, because I would like to say many things for your kind attention.
Thank you very much, Ivan. A nice presentation. Okay, so it's your first ever meeting, but maybe you know what I'm going to ask you now. What can you do for the companies in this room, and what these companies can do for you? So what would you say?
Which companies, sorry?
The companies in this room. I mean, what can the participants in the room do?
I think a lot of things can do, I know, because I see that some of them are operating in the fields which are complementary to ours. So I'm convinced that we can find a better collaboration, nice collaboration to, or either to establish, to develop common projects or common device where our experience and their experience can be integrated to reach a new products, to develop new.
And can you put an example, for example, regarding, maybe it's regarding filters for hyperspectral imaging, or regarding cameras or detectors? What are, where do you see the main challenges for developing your systems? No, because finally you are developing systems, right?
One of the, for our LIDAR systems, which are developing here, for instance, we need laser sources with very narrow pulses, narrow pulses, let's say 1 nanoseconds. We need also the sources with continuous spectrum, starting from, let's say, 300 nanometers and up to 2 microns. There are a lot of ideas. It's difficult for me not just to say.
Just to mention one, right?
But we will be in contact. I'm convinced that we will find way to collaborate very, very concretely.
Okay, do we have questions from Iman? Well, if not, maybe I can introduce you one of the companies in the room. So, well, you are going to talk later, but Kerr from Chromacity.
Hi, yeah, we, I guess this does sound very interesting for us. We are a laser source manufacturer with tunable sources in the near and mid-infrared. And also it's all pulsed picosecond pulses from kind of 1.4 microns out to 12 microns. So might well be a useful source for yourselves.
Yes, I think so. We will have opportunity to discuss more in details these topics.
Yeah, I think
separate.
You'll get a brief flavor in the short talk, and I think I'm halfway through this session at some point.
Perfect. So we will be very happy to make to be sure that you keep in contact. Okay.
Mm-hmm.
Yeah, sounds good.
Okay. More questions?
Thank
So any more manufacturer of lasers in the room? Okay.
Yes,
so,
we are laser manufacturers.
Sure.
I can also see a few others, but
I didn't see you. Sorry.
that's fine.
Okay.
To share a platform.
So, yeah. So we make broadly tunable devices in the mid-infrared and the near IR now, and they're primarily used in chemical sensing, and I think the vast majority of where the lasers go right now is in environmental sensing. So that's why we wanted to join. So we are very active also in research projects. So we've worked with some of the people in the room here, but also commercial projects. We can develop new devices, and one of the good things of what we can do is that we can actually custom make the laser to fit very specific needs. So we are used to that.
Yes, we're interested, for instance, the sources for the direction of methane, for instance. Okay, laser source for the absorption of the.
Yes, if you go on our website, there is actually one drone-based sensor that uses one of our QCLs to do methane detection in the low ppb levels.
Mm-hmm, yes.
That's on a flying sensor, so they're very stable and they're very lightweight.
Yeah, I will go through your webpage too.
Yep.
Okay.
We are very lucky to say that in Europe we have the best quantum cascade laser technology in the world, and many of them is actually represented in the meeting today. Panayotis, in the QCL market, we've been talking already for 4 years, pushing this market like crazy. You say that the environmental sensing is growing.
Yes.
When it comes to the space applications, have you seen that market segment growing a little bit? And I have here Ian Mackenzie from ESA, which I'm going to introduce you later.
We actually have one project with ESA, and that's in metrology, actually for very high accuracy distance measurement, intra-satellite, and inter-satellite can be both. And we have also one commercial project that's space related for calibration of environmental sensing. So it's on the ground validation and testing side of things. So it's not on the upstream; it's on the ground.
Ian, thank you very much for joining the meeting this afternoon. Ian and me, we live in the same beautiful city, or beautiful village in the Netherlands called Noordwijk. Ian, thank you very much for being with us. Why are you joining today a meeting and listening about environmental monitoring?
Well, actually, just wanted to hear what what's the latest in terms of laser sources and the like that are being adapted for various trace gas monitoring, to make sure that we're up to date with the supply chain.
We have seen huge investments from different companies. Leonardo, for example, looking at QCL for standoff detection in the defense sector. I really think I agree with Panayotis that there is a lot of things that we can do here on the environmental monitoring. I think the wavelengths that the technology of ALP laser and nanoplus can really manage is out of this world. And I also would like to thank the people from Fraunhofer IAF, which made me this beautiful mug. Really quite outstanding. So I would like to say that because you also make fantastic QCLs. Back to Anna.
Thank you. So if there are no more questions or comments, I think that it is moment to move to the next speaker. So William Castaings from Tenevia.
Yes, hello.
How are you?
Fine, and you?
Yes, fine. So if you want to share your screen.
We should be on now.
Yes, just go to the presentation.
Okay. So very happy to be here after meeting Jose.
No, we cannot see your presentation of your screen anymore. Can you share your screen again? Sorry.
Indeed, we met in Barcelona at the Smart Cities conference. Yeah. I stopped by their booth. It's quite amazing what they could do. I think you are sharing the wrong screen.
Yes, still is the node.
So if you have two screens in front of you, you can just pull the plug and just only work with one, and they will work perfectly.
Yeah. Is it okay now?
Yes, now we're talking. The floor is yours.
Sorry about that. Yeah, so in short term, I will present shortly Tenevia. So Tenevia is an SME located in Grenoble, in the French Alps. And we are developing products and services for monitoring and forecasting in the water, energy, and environmental sector. So those solutions, this range of solutions includes optical sensing, modeling, professional softwares, but also supervision systems. And today I will present you the two technologies, two sensors we have been developing for monitoring river flows, for helping cities managing the consequences of climate change, or providing solutions for industrial, water-related, water-sensitive industries. So the first solution we developed is a cam level, is an optical solution for monitoring water level from rivers, lakes, or dams. So the aim of the solution is to detect the water level in image sequences, and then for the camera to become really a sensor and provide both time series that you can see with the graph on the right, but also augmented images that will enable the remote check of the measurement from decision makers. So since water level is not a quantity that can help decision makers to design dams, calibrate forecasting models, we have also developed a solution which is called CamFlow. And the aim of CamFlow is to measure water surface velocities and discharge. So the image sequences are used in order to measure both the water level that you can see here on the staff gauge, but also the surface water velocities. And then those surface water velocities are combined with hydraulic modeling in order to estimate the discharge for rivers. And this is very sensitive because estimating discharge during extreme events is really challenging using the current technologies. And this optical-based solution has enabled the measurement of really extreme events that could not be measured before. So just like the previous solution, the solution provides both measurement time series, but also augmented images for analyzing the measurements. So I was very short in order to focus on those two applications. We are also working on other applications for water quality monitoring, for snow monitoring, in order to provide hydropower companies with reliable solutions for hydropower forecasting. We are also working on cloud monitoring for solar nanocasting. And really looking forward to build collaborations to have partners to leverage the latest developments from the photonics industry.
Thank you very much, William. It was really a pleasure when I went to see your booth at the Smart Cities conference, and you showed me this demonstrator. I was quite amazed with the technology and also with your team, and you all were so nice. And I told you eventually you had to come to one Epic Online meeting to present this, and I give you a very short notice, but you accepted. So thank you very much. As Anna said, this is an Epic meeting. An Epic meeting is based on collaboration. So the question, the Epic question is, what can you do for them? What can they do for you? Share us a couple of challenges.
So for me, the main challenge is that when we started those research, we started working with digital cameras, and after that with analogic cameras, and now with with IP cameras, but mainly visible, sometimes infrared. And I think there are a lot of challenges for us in order to use more sophisticated sensors like multispectral or hyperspectral sensors, and having such sensors within cost-effective solutions can really bring a lot of new applications, the measurement of new variables. So we can both leverage advancing technologies from those topics, but also provide some markets for the sensor manufacturers.
Of course, if anybody has a question, all you have to do is raise your hand virtually or physically, and I will make sure that you get the spot. In the meantime, there is very cool technology in Epic, William. And one new thing that we found recently is also coming from the city that you know so well, Barcelona. MAPSI is a spin-off of UPC, and Danny is here to tell us how he can help William on perhaps the water quality. Tell us, what is MAPSI, Danny?
Well, MAPSI, I'm Danny. MAPSI is a spin-off of the UPC, and we are mainly focused on mid-infrared silicon photonics for mid-infrared sensing. Our technology is porous, so sometimes you can use it more for biochemical analysis of water, more than for measuring water flows. But maybe we could do something with quality or measuring the quality of water. But mainly we are focused on gas sensing for filtering emitters for gas sensing applications.
Okay.
William, when you talk about water quality monitoring, what parameters do you normally measure in the water?
There are different type of parameters that can be measured. We are working on different applications for the detection of oil spills, for monitoring litter that can be on the surface of rivers, for monitoring, for example, turbidity. There are several applications we are working in at the moment, and I guess that some new sensing technologies can bring really additional information.
Oh, you will see. You will see. I have a question actually coming from nanoplus, from Lars.
Yes, thanks, Jose. I have a question. We have a quite hot topic at the moment, which is microplastic in water. So it's not natural water, but water you use in industry application. So do you have any things going on detecting microplastic in industrial water?
For the moment, we are working mainly on macro and macroplastics in rivers, and only those plastics that you can see at the river surface.
Yeah, I'm not necessarily talking about really rivers. So, for example, when you have someone doing beer, right? And if you're doing beer, you need very clean water.
Yeah.
And they want to avoid microplastic in the water they're using for their beer. So that is something which could be quite hot.
A very interesting application. Basically, we are a company developing video analytics. So whatever you can see from a visual image, or whatever the signal you can get from a thermal or hyperspectral image, we can build an algorithm based on EI or on classical image solution to provide either simple on-off detection or really, like we saw before, continuous measurements.
Okay, thank you.
So that would be interesting to exchange on the topic and see if we can provide our expertise for this specific industrial application. It'd be interesting.
You said one of the magical words in this community. We love hyperspectral. Is there any particular challenge or application field where you see from Tenevia that the hyperspectral imaging is being the right solution?
I think that one of the for the water quality problem, there are plenty of sub items for which hyperspectral can bring really interesting information. Of course, with other perturbation factors that we do not have in the visible or infrared, but additive information content.
I see that Ivan unmuted himself. Do you have a question?
Yes, I think that we can find some synergy with the activity of Williams' company with our, because from 2 points of view. One, concerning the aquatic drone that we have developed here, and it is used to explore rivers and lagoons, and also the hyperspectral imager that we have developed in order to evaluate the spectral reflectance of the water surface. So maybe we have to explore these two topics, how to find, to collaborate in this field.
Very interesting, just on the other side of the Alps, not that far.
And if you drive north, you arrive in Belgium, and then you go to Liège. And if you ever have a challenge on hyperspectral solutions, you have to talk to these guys from Lambda X. Thierry, how are you doing today?
I'm fine, thank you. I should unmute. Can you hear me?
Yeah, loud and clear.
Okay. Well, that's thanks for giving me the word. That's quite interesting topic indeed. What we are doing at Lambda X is to build the system that would embed the sensors, but definitely the application to monitor water quality should be a valid one for especially our Raman imaging system that we have developed and we propose to the community for these days for pharmaceutical or bio applications. But I'm sure, and I've heard, that for monitoring the plastic, and especially getting a volume information from, let's say, a drop of water from which could derive the distribution and the density of plastic particle and identifying the type of this plastic, it should be a valid application for hyperspectral technology, which now is targeting the Raman imaging application.
William, I told you this was a really, really cool community.
Yeah, very interesting. I think one of the other challenges is the sensor itself is one thing, but we have managed to make the survey monitoring solution very effective, because above the sensor, there is also the integration into a camera, which is an IP camera, which means that the smart camera can be connected to a data logger and send measurements just like any traditional sensor.
Any further questions? Any further room for collaboration here? Of course, needless to say, I'm going to make the introductions later. And William, it's so nice to have you in your first ever epic meeting, but not the last one, promise. We had to have you back. That was fantastic technology. Let's move. Let's continue with the program. I'm extremely excited about the next presentation. I really love this company, SENSIRION. I really love SENSIRION because they have been in the field of integrated sensor, really always open to many collaborations. And Martin is here to tell us in this community for these market segments what kind of things we can do together to make SENSIRION even better than they already are. The floor and the attention of everyone goes to you, Martin.
Okay, thank you, Jose, for the nice introduction, and hello to everybody. Yes, let me thank you for giving me the opportunity to talk to you today. Let me briefly share my screen and somehow get started here.
Yes.
It did work amazingly. Do you see my screen?
Crystal clear. It's so beautiful.
Fantastic. Okay, great. So SENSIRION. who are we? We are a spin-off from ETH, founded in 1998, and operate as a market and technology leader in environmental and flow sensing. So we're headquartered in Switzerland, close to Zurich, and currently have about 800 employees with 170 million revenue as of last year. So just to give you a rough feeling of who we are, let me jump into our products right away. We're basically making most of our business on two pillars, one of which being flow sensing for gases and liquids, and the other one being what matters to this community the most, environmental sensing. So to sort of show you, you know, where we come from, our DNA basically is the co-integration of sensor functionality with CMOS, with electronics on a chip that does all the signal processing and the readout and the interfacing with the customer. The largest chunk for us is relative humidity and temperature sensing, where we have these component style products on the left. More recently, we've been moving towards gas sensing and particulate matter sensing. With gas sensing, we basically have two flavors of this. We have electronics-based VOC sensing based on metal oxides, and then we have these more system-like, module-like products on the top right for carbon dioxide and particulate matter, and those are the products I would like to get into a bit more on the following two slides. This is basically the bridge to the EPIC community. Where do we come from? I mean, the first example of environmental monitoring at SENSIRION, again, this is close to our core DNA, the co-integration of sensors on a chip. So for volatile organic compounds, we have this technology stack where we use metal oxide nanoparticles that we deposit on a MEMS hot plate that we heat up to a few hundred degrees, and we basically derive an electric signal from a chemical reaction that occurs at the many surfaces of this nanoparticle cake. So this is not particularly relevant to what's going on at EPIC, but this was sort of our start in the field of, you know, gas sensing. Now the first step we made in the field of photonic-based gas sensing, this was our CO2 sensor that we launched about 2 years ago. So this is a classical NDIR infrared absorption-based CO2 sensor. It's a little system, you know, you have an optical cell that we integrate on a PCB with a microcontroller. There is an infrared light source, infrared filters in there, and basically a thermopile detector that we manufacture on our own based on the CMOS-based technology stack that we have in-house. And then this is a combi module, you know, that can output CO2 in addition to relative humidity and temperature. So you see, just from the character of this product, this is a bit away from what we used to do, namely these fully integrated systems on a chip. This was basically our first foot in the door of optical sensing, and but we're trying not to stop there. So we're currently working on a follow-up generation of this very sensor, which is a substantial scale down in footprint. And in order to be able to scale down, we actually had to switch our measurement principle entirely. Instead of doing infrared absorption spectroscopy there, we actually based the thing on the photoacoustic principle, which has more favorable scaling properties. So this again allows us to make the system considerably smaller, and also on the one hand enable more streamlined production on our side, and then also more streamlined integration on our customer side. So this product is fully reflow solderable and is designed for being fabricated and integrated in large quantities in the millions. So this again, the light source in there is based on a SENSIRION component that we manufacture by ourselves. This is a MEMS-based infrared emitter that basically illuminates the spectral region we use for CO2 sensing. So this is basically what's been going on at SENSIRION on the gas sensing side. Another parallel activity is particulate matter sensing, where as well we were able to enter the market about 2 years ago with our first PM2.5 sensor, SPS 30. So this is a laser scattering based sensor able to detect particles up to 2.5 microns diameter. It's a very straightforward optical system, right? We have a little box with an airflow. We shine a laser through this flow channel, and we detect basically the sparks scattered by particles that pass through the beam waste, and then we do have our special algorithmics behind that to judge the dust concentration in air. Now, with this product, we're actually working on a forward integration step that we call NUBO. So this is a node, a sensor node for smart cities that integrates this PM2.5 sensor together with relative humidity and temperature. And this is a box that you can see on the right here that can be installed in your city. It has 4G connectivity worldwide and basically allows the users to obtain high quality sensor data with very little maintenance. So this is supposed to be released early next year. And with this, I think I filled up my 6 minutes. I thank you all for your attention, and looking forward to the rest of the meeting. Thank you.
Thank you very much, Martin. Yes, and at the Sensirion, you are developing a lot of different technologies. So what would you say that are the challenges that the companies in the room can help you with? Mm-hmm.
I mean, as I said, the where we came from with Sensirion was really this idea of co-integrating sensorics with electronics, which we call CMOSense. And I think for us, classical sensing technologies like thermal or capacitive transduction, we were quite successful on this. On the photonic side, we started basically, making systems where we put together many components in a housing, but of course we would like to close the loop and also go towards integrating these on smaller footprints and in silicon photonics platforms and the like. So we're very interested in finding partnerships that allow us to do chip scale integration of sensing schemes. And of course, since we are mainly concerned with environmental sensing, one of the hottest spectral ranges for us is, of course, the mid-infrared. And this spectral area appears to have the main challenge, the light sources, right? And in particular, the strategy of Sensirion focuses on high volume markets. So we're looking into applications that we can serve with, millions of sensors a year. And we're basically trying to find our ways of how to obtain the right mid-infrared components at these quantities for the very price-sensitive use cases that we have in mind.
But do you see an important role for quantum cascade lasers in the future for some of your applications? Absolutely.
Absolutely. I mean, if we find ways to obtain quantum cascade lasers in large quantities at a low price point, this would be a substantial game changer.
Is also our desire to find a large quantity low price?
Yes. Fantastic.
What are the triggers in terms of pricing for you guys, for both of you?
Okay.
What is the trigger?
Yeah, what kind of are we talking of? Of course, everyone would love to have dollar QCLs, but realistically, for your kinds of applications,
it really depends. So for these really high volume applications, it is the dollars. For like medium instrument style equipment, I would imagine tens to hundreds or so. Yes.
And Lars from nanoplus, you had a comment?
Yeah, I kind of had the same comment like Hamamatsu. So it's always the price point that people are talking to Hamamatsu or nanoplus or Alps about. Everything has to be so cheap. In the past, we did make lasers very, very cheap, and then the applications disappeared. So that was kind of interesting. So we have some customers in an automotive industry or like your industry. I mean, we know Sensirion since some time, of course, and there's others, and they really talk about cents, not dollars, right? So
Yeah,
it's getting to sense when you're coming to. I mean, if you're talking about a mobile, you pretty much don't earn anything.
yeah. Actually, on that topic, it's interesting that Lars, you talk about automotive, because that's kind of one of the strategies that we're trying to use to move forward with bringing the economies of scale of mid-infrared down, because we're working, of course, with autonomous vehicles, and LIDAR is a very large application for us. And we're targeting that with 3.5 materials. And we're hoping that environmental monitoring, 3.5 materials that we have for detectors and for emitters can really piggyback off of that and give us access to those economies of scale.
Absolutely, yeah.
Okay, and if I can introduce you now, Martin, one person here that is in the room, Sebastian from Trinamics.
Hi, everyone.
Hi.
So I just
like to introduce yourself and how can you help, Martin?
yeah. So I heard that the emitter side seems to be an interesting topic, but I was also wondering if the detector side is also a topic that is still hot, because I mean, as I saw, you're using thermopiles. We are a manufacturer of lead salt detectors, PBSE and PBS, with the big advantage that they have a significantly higher detectivity than classical thermopiles or pyros. And the other advantage that only we have is you already talked about chip scale integration. Actually, due to an encapsulation we developed for these sensors, we can offer them in a chip scale, and you can use them in a chip scale without an additional encapsulation step. Would that be of interest, or would you say that is not at the focus?
Yeah, so thank you for your comments, Sebastian. I think we or a colleague of yours, we met at Photonics West last year. So the detector technology is definitely of interest for us, in particular when it comes to low power applications. I mean, as I mentioned before, in particular in gas sensing, we're also exploring the route of photoacoustic spectroscopy, where the sensing part is done by a microphone. But for a future low power applications, this could actually be very interesting. And the other point you mentioned, the encapsulation, I'd like to get back to you about this, because this seems it is basically tricks like this that help SENSIRION get big. Some specialized processes that help you to make to really make a sensor out of an electronics chip. It seems to be in a very similar spirit what you mentioned. So this could be very interesting to explore.
Would be very happy to pick up on the discussion we already had, and also with the other guys. I think, as you said, it's one thing is the performance of the detector or the performance of the component itself, but the other thing, and we see that as crucial, is how do you integrate it in your overall optical systems? Because we mentioned price. Yes, price of the individual component is important, but if I can, by other performance parameters, reduce the price of other parts of the whole assembly, and optical systems are always a complete assembly. I mean, price is important, but the overall package has to fit, and I think that's where we can provide a big advantage.
Okay, yeah, that sounds interesting. Thank you.
William, only one point. You're already using your sensors for particulate matter. So
you're happy with the quality, right? They are great sensors. From the YouTube universe, I have a question from Finland, from VTT. My very good friend Philippe Monoyer, he's wondering about the PM2.5 device. He's wondering what is the smallest particle size detectable?
As far as I am informed, with our current technology, it's around 600 or 500 nanometers. It's basically given by the wavelength of the light that we're using to do the basically the laser scattering on.
So it is half of the wavelength.
Roughly, yeah.
All right. So a shorter wavelength will give you a better resolution on the 500 nanometers is quite amazing already. But are you interested in shorter wavelength lasers?
We have been exploring this route indeed. The issue there again is price. In fact, the particulate matter sensing business is extremely competitive and extremely price driven. So it's really the lowest prices you have to go to be successful.
If you want to go lower price, well, price in the fantastic cost effectiveness, because I've been told not to say ever lower price. Do you know the company Senorics? Because these guys are truly amazing. And my friend Christian is here. Christian, how are you doing today?
I'm fine, thank you.
People here are worried about the cost of the laser, and I know that the Senorics have been playing quite a big role of bringing spectroscopy to the consumer market. What do you have to say to Martin and to their companies here about what SENSIRION business line is?
Yeah, so bringing price down is always a very good issue. I mean, we just starting moving into business. We are a startup located in Dresden in Germany, focusing on multimodal sensing solutions. And the final goal, of course, is to really bring the price down. And I think we have a very good technology that can realize this. So I'm not talking about cents, but some dollars range, I think, is reasonable. At least in some time, which we still have to go. But that's really important in many applications. Because if you come up with a solution that costs 500 or 1,000 euros for spectroscopy, then you're very quickly out.
Okay, and Christian, what do you think will be then the perfect partners for you from the companies that are here in this room?
So, as I said, we are providing the sensing solution, and the goal for me to join this meeting was to have a short look into this market, which I have to admit is not on our top range, but we're always interested in a lot of applications that we can serve and put our technology in. So what our sensor is capable of, it's a spectroscopy in-chip solution. So it's not only a simple detector, but it combines the detecting unit with the spectrometer on one chip, which is mainly in the NIR. So at the moment targeting around 1100 to 1800, which is not enough to detect maybe CO2. But environmental sensing goes well beyond. I mean, we have been talking about the microplastics, for example. So that is something that I guess could be done this wavelength range. But we can also go to the visible if this is necessary. So if there's any problem, of course, we are always, as a technology provider, relying on the challenges that is brought to us. So if there's anything, then we're always welcome to discuss and talk, and then you can think about what is possible.
Okay, then thank you. So questions or comments for Christian or for Martin? Okay, so if not, let's move ahead in the agenda. So now it's the moment for Fabien Dherbassy, director at Ineso. So Fabien. Okay, you can unmute yourself. Very good.
Okay, I'm going to share my screen. Okay. So thank you, Jose. We met together in
Would you mind to go
in Barcelona
to presentation mode?
Yeah, it's done for me. No, can you see?
No, then you have to share the other screen. You can go up and just change the screen.
I'm lost.
No, up more in the middle.
I was really impressed when I met Fabien, when I met Ineso at the Smart Cities conference, because these people really are translating what this IoT business seems to look like to challenges that we can address with OEM modules and actually at the end, ultimately with photonic technologies. And that's why I think it was really interesting to have Senorics presenting just before, because this is the perfect bridge towards going to the large volume that IoT is demanding.
Sorry, share again, yes. Fabien.
Okay, you can see my screen now.
No, not yet. You need to share.
Yeah, but I'm trying, but I don't know what's happened. Okay. Can you see it now?
Yes, perfect.
Yes.
Okay, and now.
Okay.
Perfect. Okay.
Crystal clear.
So Ineso, welcome to the ATIC City. So well, it's in French. Sorry, I got the wrong version. Anyway, I'm gonna do it in English. So Ineso is an integrator, IoT integrator, a platform for smart city. Sorry, it's not the wrong slide.
Fabien, just feel free to change it. It's really okay. We have 2.5 hours, and if you want, we can go to the next speaker. Then you can find out exactly the file.
Go to the next speaker. Sorry.
No, but we will come back to you because I cannot imagine how interested I am on the IoT business that you are enabling. And I called you on Saturday morning asking you for this. But we're going to go to the next speaker. We're going to go to a company in the ultra-fast laser business. I really love these guys because I really want to understand the business for nanosecond and picosecond laser pulses in the environmental monitoring market. Let's go to Chromacity. Let's go to my very good friend, Kerr Johnson. Tell us about the business of lasers environmental monitoring, and especially how can we help you be even better. The floor and the attention of everyone goes to Chromacity.
Thank you. I'll just share my screen. Wait, I can't share while another person is sharing. Sorry.
Don't worry, we'll solve this for you.
There we go. Thank you.
It's maybe me, no?
I'm in now, don't worry.
Okay.
Is that going full screen? There we go. Okay, yeah, first off, thank you for the invite. And I'll try and give a bit of background about Chromacity. So it started off as an ultra-fast laser company in Edinburgh in Scotland. And yeah, I guess the whole company started around the production of a 1040 nanometer fixed wavelength source, primarily geared for life science research, two-photon imaging and the like. And it provides 150 femtosecond pulses at 100 megahertz and average powers around 4 watts. And we've developed a very efficient and stable lasing process. So this means an air-cooled, compact, fairly cost-effective femtosecond laser. And then we expanded and used this to drive a number of other fixed wavelength sources. So we also make 520 nanometer and 350 nanometer fixed wavelength sources. But yeah, today I thought I'd talk to you about our other technology. So we expanded the 1040 core technology to drive a number of optical parametric oscillators, spanning the about 1.4 to 12 micron ranges. And we tried to make these as compact as possible. There's no water cooling, etc., and as affordable as possible. So yeah, they're, I guess, well suited to FTIR spectroscopy in the context of environmental monitoring for a number of reasons. So yeah, I suppose I should first describe the overall source characteristics. It's a pulsed source, so 1 to 2 picosecond long pulses, usually supplied at 100 to 300 megahertz range, and the wavelength is tunable in the standard product from 1.4 to 4 microns. But we also have a different nonlinear crystals where we can access the 5 to 12 micron wavelength range, and they give fairly high optical powers, 250 milliwatts to 1 watt, depending on where you are in the spectrum. So in the context of environmental monitoring, we see it as a light source which can be used for Fourier transform IR spectroscopy to measure absorption spectra of relevant gases. So the CH, OH, NH bond stretching modes all lie in this wavelength range. And in particular, we see it is suited to remote measurements. So by remote, we mean the instrument not located at the point of emissions, and yet it would be suited to fugitive emissions from anthropogenic sources such as the oil and gas industry, etc. And especially when there's multiple species present, and maybe when multiple sites need to be targeted using the same instrument. So the Chromacity OPO is suited to this for a number of reasons. It's got good beam quality, meaning that you can do high resolution FTIR spectroscopy. So you can distinguish these narrow spectral lines of small gas molecules. And this good beam quality, coupled with high brightness means measurement over long path ranges are possible. So that results in high sensitivity and then obviously the ability to conduct remote measurements. And it also has broad bandwidth. So we're talking in the kind of few hundred nanometers out at the 3 micron range. And that allows you to probe multiple species simultaneously. So yeah, I think I would give an example next of this type of spectroscopy, and I should say that we're at the early stage of using these OPOs for environmental monitoring. So we've partnered on a few projects with Heriot-Watt University, also in Edinburgh, kind of proving the technology can work. So I thought I'd highlight this recent paper using the OPO to simultaneously monitor remotely methane and ethane concentrations, with a common goal for quantifying fugitive emissions from the oil and gas industry. So it's Fourier transform IR spectroscopy. The OPO emission is coupled into an interferometer before sending it to a distant target. Light scattered or reflected back is collected by a telescope, Fourier transform to give the spectrum, and that includes the absorption features from gases in the light path. So this was shown for methane and ethane, but it's applicable to all molecules with absorptions in the accessible wavelength range. So carbon dioxide, nitrogen dioxide, etc. In the example shown, you can see on the right-hand side graph there, the envelope of the OPO light is clearly modulated by water and methane absorptions, so we can extract methane concentration. And this example is for a range of 70 meters and no precision retroreflector target, so scattering just from a rough foil. But the technique is applicable over kilometer wavelengths if you have precision retroreflector at the other end of the beam. And for this short 70-meter range example and rough scattering target, we get precisions from the Allen deviation of around 40 parts per billion. So that's the kind of classic remote hydrocarbon detection use of this OPO. But I thought I would also give an example of another scenario we're exploring, in which the OPO light is delivered to the environment of interest via optical fiber. Yeah, so mid-IR optical fiber, either zirconium fluoride, or we've also used some hollow core silica fibers, can deliver the OPO light to environments which would otherwise be inaccessible or hazardous, but can have an impact on the environment. So you'd be looking at kind of process monitoring, reaction vessels, pipelines, exhaust flues, etc. And again, this is infrared FTIR spectroscopy. So the OPO light is coupled into an interferometer before launching into the fiber. And the output of fiber enters the environment of interest. Here, in this example shown on the right, is simulated by a gas cell, and a detector at the distal end of the fiber measures the spectrum. The example shown is actually in the context of a closed environment in which the buildup of specific hazardous chemicals must be monitored. But it demonstrates the flexibility of the high resolution yet broad bandwidth solution. So it allows quantitative simultaneous detection of multiple hydrocarbons in a kind of cluttered environment. I guess, yeah, I show this example because it highlights in particular that it can be used for a combination of simple and complex hydrocarbons, so some with narrow line-like absorptions like methane and ethane, but others with overlapping broad absorptions that you can see in the example there to the right, and that we can quantitatively determine how much of each one is there. So yeah, with these two examples, I'll end. And thank you for listening. And if you're interested in integrating any of our ultra-fast lasers or OPOs into your solution, please do contact the sales at chromacity.lasers.com. Yeah, with that, I'd take any questions.
Thank you very much, Kerr. Thank you for a great presentation. I'm a huge fan of femtosecond lasers. I think you should know that. We organize so many meetings on femtosecond lasers. I'm getting goosebumps because the technology that is being developed right now in the EPIC network on femtosecond lasers by you, by Class 5, by Valo Innovation, by Fluence, I never seen something like this in the laser business a long time. We have the best lasers in the world right now. And we have questions for you. But before that, the epic question. What can they do for you? What can you do for them? So
I guess really we're interested in any partnerships where people think they our light sources would be useful and to partner with on a project. So we're obviously not in the business of very small, very cheap lasers. These are more, I guess, kind of higher specification types. But yeah, could be if you think it could be useful in your projects, we would love to hear.
We have questions for you. We're going to go first to Hamamatsu. Adnan, what's in your mind?
Yeah, so I just wanted to ask Kerr, thank you for your presentation. Within your OPO device, do you do any active power beam monitoring with a mid-infrared detector of a sort?
So I guess the current one that we supply, we don't, but we're currently developing. So this is a picosecond OPO. If we go to femtosecond OPOs, we will need to obviously do this. So this would be an area of like upcoming interest.
Sure. Just because we're talking to a number of high speed or high power laser manufacturers that are sort of moving into the mid-infrared, and that's where we're seeing a lot of interest in our fast detectors. So that's interesting to know. Yeah,
that would be good to know, because for the spectroscopy stuff, it doesn't need to be that I showed there. Doesn't need to be so fast. But if we're in the cavity monitoring, this would be good.
Okay.
Lars for nanoplus.
Yeah, Kerr, I have a question. Thanks for the nice talk. The main advantage of OPOs is the large tuning that you have compared to DFB lasers, which are, I mean, they're tunable and you can do pretty easily methane and ethane at the same time. So I guess you will not find many customers really. What customers come to me is, can you tune 2000 nanometers, right? And that is always where I can sell 2000 lasers, and then I'm at the high price range. But that is for liquid detection, right? So do you have any activities going into liquid detection or really large molecule detection where a small DFB laser cannot work anymore?
No, that's really what we would be looking for, is any applications that people would use this for. Currently, we've not done too much in that region at all. We've kind of we've done some work with bigger molecules, so broad absorptions, but mostly in the gas phase.
My feeling always is when we are talking about photonics, there's many laser jocks going around like me or Kerr or anybody, and they're doing all lasers, right? So they have nice lasers, and then they're looking for the easiest application, which is gas spectroscopy. But that is not the real problem sometimes. So I suggest you go into liquids and larger molecules and not talk to laser jocks all the time. So then we're going in circles, right? And that is what exactly EPIC is doing for, right? So I love the job of Jose and Anna, that they are just bringing people together and asking the stupid question all the time.
Yeah, that's good to hear.
I love asking stupid questions. So we talk about, we are the laser people. Let's talk about the spectrometer people. Let's see how they see this market. I have a really fantastic Mac from a company in Copenhagen, Ipsen Photonics. Thank you very much for joining today. Did you see the comment from Lars? He's saying, okay, why do we always go to the easiest solution? Let's investigate the market. Ipsen has from the visible to the 2.2, 2.3 micrometer wavelength, different spectroscopy solutions. How do you see the market of environmental monitoring for Ipsen?
That's a good question, Jose. I hope you can hear me. Okay, so I think we're probably along the same line as from nanoplus, that I think we've mostly used when we are in the environmental monitoring. It's typically gas detection. So we're probably in the same line gone for that kind of areas. So I think a lot of things are going on there. And as somebody else also commented on, I mean, the price has to come down. But I think that some of the things that is happening is you can do a lot with really simple sensors. But in some applications, you would like to add many gas lines in one module. So you may be able to live with a little bit higher price and then use a spectrometer or maybe a little bit more expensive laser or something like that. But it has to be at the, I mean, you have to, of course, to have some benefits, which will typically be that then you can maybe monitor 5 or 6 or 7 or have a more versatile instrument that can be used. Maybe you can produce it in higher numbers and then use it for different applications. But I think in this area, we are mostly also in the gas sensing.
So for me,
actually, one thing I wanted to comment, because there was something about the microplast also. What I'm seeing is also in liquid applications. So somebody mentioned Raman spectroscopy, and I think that's also a very interesting technology that we're also at least starting to scratch the surface of, because you can look into tanks or probably also rivers and things like that with Raman. And then monitor at least organic molecules and different things in there. So I think that's also something we're seeing rising.
Indeed, the business of Raman spectroscopy is rising, especially in the agriculture sector. Actually, we're going to have a meeting on photonics for agriculture, and most of the interest right now is coming from companies who are telling me, I have Raman technology, I want to see what to do in this market. That's rising like crazy. Interested still of how the companies are seeing this market. For me, one key company in the EPIC network is Axetris, all the way from Switzerland. And for me, the nice story of Axetris is that in the beginning they were, well, they are micro-optics company. Rui, are you with us?
Yes.
Yes, but little by little they said we need to go higher and higher to solve our needs, and now they actually make OEM modules. In the business of gas sensing, environmental monitoring, what does Axetris do, and how can you help these people a little bit?
So we have several product lines actually at Axetris, as you mentioned. Yeah, we have micro optics, so micro lenses, all the way from the UV to the micro MIR, and we have now also laser gas detection. So we put together a module, and we do gas sensing. Typically, we have a compact module to measure methane, ethane. It was interesting to hear from Chromacity, because exactly one of the application we are serving today is the simultaneous measurement of in one device of methane and ethane for leak detection in the cities, and see if it's what kind of gas is there. Is it a natural gas or a city gas? And in terms of environmental gas, we are measuring also ammonia, also HCl, and looking a bit what is possible, because we are limited in the near infrared up to now. We go up to 2 micrometers, so limited still in the species we can measure, and looking now also as a bit everybody here to mid infrared and see if we can integrate. But as said before, the price for now is still a problem for us to integrate mid infrared lasers or QCL lasers, and we are still on the couple of $1,000 devices. So this is why we keep in the NIR for now. Yeah.
One thing, I'm a big fan of your company, huge fan of your company, and as well, we love Axetris. We've been looking at all your product line and talking to all your people at different market segments. You're pushing a lot the thermal infrared sources for the environmental monitoring market. Is that mostly based on cost, price, functionality? Is there a new area in the semiconductor lasers, semiconductor LEDs, superluminescent diodes, companies who could you think that they are booming and they could maybe enter the market?
It's a good question. Not for now, I have to say, not for now. So we are pushing, that's true. We have also one product line, which is manufacturing IR sensors, IR sources, broadband then. And this, yes, in agriculture, I think in the environmental or in agricultural market, you need to have the price again has to be very low. And this is why we are pushing for NDIR sensors with our IR source. Yeah. And also for TDLS, as we are using for the laser gas detection, I think this is also a key for agricultural markets to bring down the price. But for now, the source is, yeah, I don't have better than IR source for now.
Lars.
Yeah, of course, I cannot agree that the sources are too expensive when I'm in a conference like this. we're selling many of these lasers for the price that they have now. And the discussions we have with large volume manufacturers, we're really discussing cent prices, right? 10 cent, 15 cent, 20 cent. And that is for a QCL, and that is for an interband cascade lasers at above 3 microns. But they go to volumes in the hundreds of thousands up to millions, not a few hundred per year. So if we have applications a few hundred per year, then of course a semiconductor laser is not the right choice at the moment, if it's not co-sponsored by telecom, for example.
You could see that, for example, VIGO Systems in Poland is investing heavily on making production of mid-IR material, just because they do know that the future, the quantum cascade laser and the mid-IR detectors are going to decrease in price, and that's going to happen naturally. I honestly,
absolutely, yeah. So and Hamamatsu is doing the same, nanoplus is doing the same, right? So we are all investing in production lines. I mean, you know the project we're having with EPIC. There you have a pilot line for large volume, and here it goes about large volume. And large means a couple of number of zeros behind the one.
I think we have a question from Bill from nanoLambda. Do you have a question? Hello, Bill. Do you have a question? Yes. I think I saw you raising the hand. Yes.
No, I didn't intend to ask a questions. Yeah, I thought it's next turn is my turn. So
it's going to be one after you, because we're going to go first to Ineso. We're going to go to Fabien now. And the reason for that is because we are talking about price. And I am very black and white on this. I think semiconductor lasers are cheap by nature because they're a piece of semiconductor, and that's cheap. And I want to understand from the IoT business, what is the demand? And from that, when I met Fabien at the Smart Cities conference, I really fell in love with what these guys do. And I want all of you to share that passion. Fabien, merci beaucoup. Thank you very much for being with us. The floor and the attention of everyone is yours. We see it crystal clear now. Yes.
You can see my screen?
Yes.
Okay. You can hear me as well?
Loud and clear. The floor is yours.
Okay, perfect. So Ineso is the IT company. So we are an IoT provider providing a full solution from ecosystem of equipment device to software architecture, middleware, and to a cloud service platform. So we did already install our technology in Abu Dhabi, San Francisco. So we're working on 3 main markets: the energy market, air quality, and mobility. Of course, we have a design capacity, so we're able to design the homemade sensor for special need. So we provide CT and companies with plug-and-play infrastructure to fit the new economic, security, societal, environment challenges. A short example, we have a solution for lighting, for mobility, parking, air quality, and as well some solution for garbage. So I'm going fast. Our solution, so equipment, sensor, and then collect and transmit the data. We have as well algorithm to analyze the data and bring digital intelligence. For example, to alert in real time, to do as well a prediction, and then services platform that are available in the cloud or in the proprietary mode. And as well, some citizens applications, and especially in air quality, with advice, with alert, depending the quality of the air. So air quality is responsible for 7,000 deaths per year in France. And as you said, Jose, more than 1 million people, more than 1 million deaths in the world per year. So it's one of our sensors. So we're able to measure, to pilot, to communicate, and to provide to citizens good practice. We're doing real-time measurements. All sensors are geolocalized. And we are able to measure thin particles from PM03 to PM10 with humidity and temperature. All the sensors working on mesh network, completely free. We don't have to pay for the communications. So it's radio communications, mesh radio communications. We're able to configure the sensor. For example, we want to connect data every hours or every 10 minutes or every 15 minutes. So we're able to configure the sensor through our applications. Some application, clean rooms, high technology, construction. So we have two kinds of sensor as well. We have a sensor a bit different for clean rooms, for example. Some installation is in, so we have already done job in San Francisco, in China, in Abu Dhabi, our public partners, the French Technologique and BPI France. Thank you. So if you want to contact me, you have all my information on the first slide here. That's all.
Thank you very much, Fabien. It was super nice, a super nice presentation. Okay,
thank you.
Yes, no, thank you. So then about what are the gases, or what are the most interesting applications for sensors?
So we're only focused right now on thin particles and humidity and temperature. But tomorrow, of course, we're interested to integrate and to measure more gases. Outside the CO2 is not, we're focused on outside measurement. So CO2 is not really interesting, but we are looking for other sensors to be able to measure other gases.
So to measure particles is the most interesting application right now?
Right now, that's we are focused on. But tomorrow, of course, we are looking for to integrate other sensors, other technology to be able to measure other gases.
Okay, and what are the challenges? Okay, I can see. Okay, I can see there are a few questions. So let's go first for this. Rui from Axetris, you had a question, right?
Yes. Yes, we were talking about gases you would like to measure, and interesting for us because we do compact gas sensing, gas sensors, and I was wondering what kind of price range is acceptable in such an application for gas sensing, for example.
Well, it's hard to say. Of course, we are not. I mean, a couple of $100. I mean, the full product. That's the price range we provide to cities. Like a sensor for us is like less than $200, and if we have more quantity, it's less. It's less. So we are in small price, and to deploy a maximum of sensor in a city to have a maximum of measurement point.
Okay, then regarding challenges in your technology, so what are the collaborations, technological collaborations you would like to establish? I mean, in this meeting.
As you can see, we are an IoT platform, so we are looking for new technology to integrate those technology inside the device that we can link to our platform and provide new services to our customers. So we are completely open. So I'm not the technical guy here, but my technical team will check what we can integrate to the platform and get connection to the EPIC members.
Okay, perfect. So there are more questions or comments? Okay, because if not, I would like to introduce you here, David. David from Glenair. Hello, David, are you here?
Yeah,
okay.
yeah, I'm here. I'm just unmuting myself.
Okay, will it be a good moment for you to introduce?
It's Devinder from Glenair.
Okay, would you like to introduce what is Glenair doing in the packaging field for the environmental market?
Well, we are actually we have a very strong capability in optoelectronics and photonics, specifically in the optical communications area, and we design and manufacture ruggedized optical transmission solutions to enable equipment to be interfaced with fiber optic communication lines. So in the case of today's online meeting, for example, I'm expecting that many of the equipments that will be developed for environmental sensing will be located in harsh environments. And in many cases, within those harsh environments, if you need to transport high levels of data, for example, high resolution imaging or other very high resolution files, it's not often easy to go long distances on copper lines, on traditional copper twisted pair or coaxial cables. So what we bring to the table is the ability to offer ruggedized fiber optic transceiver transmitter solutions that can be designed into these equipments to enable the equipment designer to transmit their data very, very reliably, securely, and with high fidelity over longer distances. Our products are actually targeted for a very wide variety of markets, including space, satellite applications, including the oil and gas industry, including, of course, defense, avionics, aerospace, nuclear power, big science, particle accelerator, those kind of applications. So I was really joining this meeting to understand perhaps what some of the bandwidth impacts might be on the equipment that is deploying these remote sensor technologies, and what the challenges could be in getting this data connected from point to point.
And do you see any potential collaboration with any company in the room?
Well, I mean, we're looking for collaborations all the time, in particular with equipment or box manufacturers that would like to utilize the features of transmitting data over optical fiber, utilize the benefits of doing that, of which there are many. So, I don't have a particular company or collaborator in mind, but in general, this is how we are moving in the market, moving forward in the market.
Okay, very good. Any other question for Davinder or for Fabien? Because if not, I just saw...
Yes, I have a question, Anna.
Okay, sorry.
Yeah, maybe you don't see me because it's so many people here. I have a question for Fabien. I see the Internet of Things it could be dramatic change in our lives and in our environment. So, and semiconductor, they naturally go very cheap with high volume. So, of course, the photonic semiconductors would be interested to go cheap. That is what this community is about. My question is, in general, the Internet of Things people who do the instruments for IoT, do they in particular look at photonics, or is that just one technology out of 100 different technologies? Can you comment on that?
It's one. I'm not a technical guy, but what I think is one technology, and we use of course other technologies that I think only for environment. I think is very interesting, definitely. For environment issue. And I think this new generation of microsensor is completely new. And if you've seen in France, you have like 3,000 stations to measure the pollutions. And with those microsensor, we can deploy a large number of the sensor on the country, and to be able to have a better measurement and have measurement in real time. So of course, price is very important, and
yes, of course.
I think the volume will increase fast the coming years, definitely.
Okay, thank you.
Question from me, Fabien. I've been attending many conferences before the whole world fell apart, and especially in the environmental segment, we always go down to VOCs. VOCs for water contamination being a huge issue. Have you seen something related to that as a market trend? Are you looking at that particular segment? Because if that is the case, we do have great technology for characterizing VOCs in water.
Yeah, of course.
EPIC.
Of course. I think when we talk about pollution, many cities around the world are very interesting about this technology and how to integrate fast those technologies. That's the point with end-to-end solution, turnkey solution. That's very important. They don't want to spend time to talk with many actors and spend time to integrate the technology. They want now turnkey solution with all tools in terms of data analytic and data mining and alerts and so on. That's the point.
Fantastic, Fabien. It's so great to have you in EPIC. I'm so happy to have you here.
Thank you.
Not the last one. Promise me to have you again at EPIC events. You are great. Back to Ana Gonzalez.
Thank you.
Okay, thank you very much, Fabien. So then if there are not more questions or comments, I think we can move ahead in the program. So we have next presentation is from Bill Choi from nanoLambda. So Bill, if you want to share your screen. And thank you, Bill, because I know it's very late in your place now. Okay, and now you can go to presentation mode.
Can you see my screen?
Yes, we can see and hear you very well.
Okay, hello everyone. My name is Bill Choi from nanoLambda. I'm in Korea. It's already close to midnight. nanoLambda is a small startup company in Korea, and we are trying to develop and manufacture the world's smallest optical spectrometer for IoT. Unlike other the typical conventional spectrometer solutions, which use typically gratings, we use totally different technology, digital nano filter array technologies, and making the size and cost less than 1%. We are targeting about close to the $10 or below. Especially targeting the IoT and the consumer and the wearable mobile applications. Although the size and cost is very low, the performance is actually close to the commercial level spectrometers. These graphs you see here on the screen is actually measured by our sensors, spectrometer, the light sources like halogen and white LED and 395 nanometer LED plus 940 nanometers and 355 and 850 nanometers, which means the wavelength ranges our current sensor can measure is from 340 nanometer to 1010 nanometer, from UV to near IR range, very wide, and it's working very nicely. And what we are offering now to the market or the potential customers is a development kit and the actual sensor module. We call it NSP32M modules, and the application devices, especially for the light measurement. So it's a spectral radiometer, which can measure spectral power distribution or watt per meter square or lux, or for the PPFD DLI for agriculture applications. So with this small size and low cost, we targeting we pursue the accurate and low cost health monitoring anywhere. It's health means it's not just for people, but people and plants and planet. And for the people, I think the health monitoring is very popular. The heart rate, blood pressure, and oxygen level and so on. So our sensor can actually measure heart rate, oxygen level, and blood pressure. And going forward, we also target the glucose. Also, it can measure many things about the plants. But today's the topic is environmental monitoring. Our sensor can be used for water quality monitoring and air quality monitoring. This one is actually the actual measurement I did in 3 years ago on top of our office building. On the right hand side you see the very clear the blue sky, but on the bottom side you see it's a very air polluted scenery for the exactly same area. So for these two sky, using the sunlight as a light source, we measured the spectrum from the sky, and the blue curve definitely shows the very similar to the typical sun spectrum. But the other red and the gray color curves measured toward this direction, multiple different directions, showing some distorted spectrums, which means it has many different kinds of PM 2.5 or PM 10 particles, but we didn't have a chance to analyze what the content is. But we definitely think this could be, it has a good potential to contribute for the air, the environmental monitoring. So what we are looking for is the collaboration for nationwide or worldwide real-time air monitoring. As a small sensor company, we would like to collaborate with a system integrator, but also the data analysis and so on, so that from the smartphone or from the moving cars or the street lighting poles or small weather stations, our sensor can be integrated into any of those. And with that, you can, I believe in the long term, we can measure the global air pollution real time. That's a big vision, but as a small company, we definitely looking for some collaborations. That's what why I would like to join this meeting, and I really thank the EPIC organizer for accepting our presentation, and also special thank to the EV group in Austria, our partner company for our sensor mass production technology. Thank you very much.
Thank you very, very much, Bill. I am looking forward to meeting you at CIOE after summer, because that's where we met last year, and you have really great technology. Thank you very much for being with us. We have questions for you. The first one is coming all the way from Proambiente. Ivan, what's in your mind?
Okay, Bill, on your second slide, you have shown the measurements and the sky color. Can you show your second slide? Anyway, I continue. So the measurements of the sky in only with the color, and to evaluate the presence of the pollutants, can be affected by the absorption in the stratosphere. If you speak about the pollutants, some of them strong absorption can occur in the stratosphere, especially in lower elevation solar angles. Do you using some models to retrieve the concentrations of the pollutants, or you use only the measurements?
At this moment, we just try to show the feasibilities. So we have measured different directions with the different angles, with the different apertures, like 5 degree or just 1 degree or 30 degree for different FOVs. So it definitely shows different the result. but we didn't have a chance to opportunity to build up such models together with accurate databases yet. So that's why one thing we are looking for as a partner.
You don't use inversion models to retrieve the concentration of the pollutants. Okay, maybe here we can help somewhat, but it will be discussion after it.
That's what it's all about, discussion and collaboration. Yes. The next question comes from Hamamatsu.
Hi there. Thank you, Bill, for your very interesting presentation. I just wanted to ask, because you mentioned that it is a startup, is nanoLambda going through any serious investment?
Yeah, actually it's a startup, but we are more than 10-year-old.
Okay.
We've been working on this one a very long time because it requires a total of quite different manufacturing technologies. Yeah, we received some fundings, but we're also looking for funding especially from strategic partners.
Yeah, so this is where I think it might be interesting to have a conversation. Just to give you some information then, so Hamamatsu has relatively recently been starting to sort of do these kinds of investments in strategically interesting technologies that are have synergies with our own internal technology. So we're trying to invest into the ecosystem really. And I think nanoLambda's technology in terms of very small filters for very small spectrometers, I think might fit quite well. So I think it is a potential to have some discussion about whether there is a collaboration opportunity here.
Bill, you cannot complain, what Epic can do here. and no finder's fee, but if you have presents for Anna, she loves stuff, so you can also send us something. I think Fabien has a question for you.
Okay, sure.
Yes, thank you for your presentation. I have a simple question. Your product, your technology is market ready? Or?
Yes, we are selling our mass-produced samples through online store. Yes.
Okay.
And or you can contact me anytime. Then we can.
Yeah, I'm gonna
discuss it
my
further.
technical team gonna contact you. Yes, for sure.
All right.
Bill,
thank you very much.
Welcome to Epic. And you know, you got great technology. I want your logo here. So you know what's your next step. Sure. The ball is in your court. I'm waiting for your membership form. Thank you very much for a great presentation. It was really, truly great to see now that we have entirely the supply chain together. And I go to one of these companies who I just love. Because first of all, my wife is Polish. Second, because I love Warsaw. And third, because I love when a company starts from the name of a Spanish city, Vigo, and grows into becoming a vertically integrated giant into the mid-infrared technology. Thank you very much, Encubie Parcho, Karolina, for being with us today. The floor and the attention of everyone is yours.
Hey, thank you very much for nice introduction. Hello, everyone. Okay, I should share my screen.
I should tell at this moment that Anna is preparing an amazing meeting at Vigo in Warsaw in October, but she will tell us during the Q&A afterwards. I think, Karolina, you are sharing the wrong screen, but you're going to tweak it right now because I can see that you are doing it.
Okay,
yes,
it's okay now?
Perfect, the floor is yours.
Okay. Hello, everyone. My name is Karolina Ogrodnik. I'm a technical support engineer at VIGO Systems Sales Department. The topic of my presentation is infrared detectors for gas detection. VIGO Systems is a designer and manufacturer of epitaxial semiconductor materials, infrared detectors, and integrated detection modules. We have over 30 years experience in manufacturing of products for photonics and offer the best quality to price ratio. We can develop OEM and non-standard solutions which allow to create products dedicated to specific applications. VIGO is a coordinator and a commercial partner in many national and EU research projects. 4 years ago, we joined the MIRFAB project, infrared photonics devices fabrication for chemical sensing and spectroscopic applications. MIRFAB offers devices for companies for prototyping and manufacturing customized sensing modules based on mid-infrared technologies, so we invite you for cooperation. VIGO is also partner in 2 research projects in the field of water quality control, Water Spy and Aquarius. However, in my presentation, I will focus on air quality analysis. Emission and emission measurements of, for example, car exhaust and greenhouse gases responsible for global warming are required to help to establish efficient ways to ensure our common health and future. Many gases are hazardous. They might be highly toxic. Thus, gas sensing systems are needed to ensure a safe life. Natural gas is still one of the most important energy sources, but mixtures of air and natural gas can be highly explosive. Leaks at gas wells, gas distribution infrastructure, refineries, power plants, and private homes have to be detected as quickly as possible. Also, combustion process in coal-fired power plants or waste incinerators have to comply with emission monitoring. Mid-air gas sensing plays a dominant role among the various gas sensing techniques. The most important gases are molecular gases and have strong rotational vibrational absorptions in the mid-infrared spectral range. This is illustrated on this plot. Detectivity is not the main reason to use mid-air gas sensing devices. For industrial applications, selectivity is of equal importance. Mid-air fingerprint of different gas molecules can be spectrally separated. It allows to avoid false alarms by cross interference to background gases. A further reason is stability. For many applications like infrastructure installations, a sensor needs to have a long lifetime and stable response. This can be achieved with medium wavelength infrared devices. Depending on the application, the sensor design range from sophisticated laser-based devices with a high resolution to compact, non-dispersive infrared sensors. Gas sensing systems can be classified into 3 groups. VIGO can provide the right solution for each one of them in terms of parameters and prices. A gas analyzer is an analytical instrument which measures the concentration of one or several gas components. It can reach ppb or even ppq resolution. These type devices have to mostly comply with the regulations for a given application. Thus, the recommended our 4-stage thermoelectrically cooled infrared detectors and the detection modules with wide spectral range, very high detectivity, and frequency bandwidth exceed 1 GHz. In our offer, we have also auto-balance detection module for differential optical signal detection. It uses 2 individual infrared detectors, signal and reference, which are precisely matched to achieve very high common mode rejection ratio. We can also provide multi-element devices. They allow to obtain high quality measurements of the whole spectral range in a short time and to eliminate usage of filters and mechanical elements for scanning spectrum. A gas detector is a device detecting a particular gas in a certain area. It can reach ppm resolution. For this group gas sensing systems, we recommend our thermoelectrically cooled detectors or all-in-one universal detection modules. For R&D stage and prototyping, programmable detection module will be the best choice. And the last type, a gas sensor. It is defined as a basic sensing device indicating a certain gas concentration level or alarming that the gas concentration is out of a predefined range. For this type devices, we recommend our uncooled detectors. A perfect solution might be our new revolutionary, highly integrated detection module, AIM series, with uncooled detector integrated with low noise preamplifier in TO8 package. For spectroscopy techniques with coherent sources, the main problem is Etholonic phenomena. We developed anti-fringing solution. It means elimination of all parallel surfaces by wedging the window, wedging the structure, and wedging the top of the detector package. With applications of this technique, we are able to significantly limit interference fringes. Green line represents standard detector. Black line shows the effect of anti-fringing solution. Thank you very much for your kind attention.
Okay, thank you very much, Karolina. Very nice presentation. So, okay, maybe you can tell me now about our question. Can you tell me now what are the challenges that you would like to meet during this meeting?
Could you repeat your question?
Yes, sorry. What if you have at VIGO any technical challenge that the companies that are in this meeting can help you with?
Yes. Yes.
I mean, you are doing plenty of things, so maybe you can select one topic and tell us about one of your technical challenges. Or what are the I don't know, maybe micro optics or maybe, I don't know, other kind of epic wafer fabrication. What are the challenges that you are facing?
On last slide of my presentation, I mentioned about great advantage of VIGO detectors, anti-fringing solution, but there are many causes of this phenomena. So we would like to invite for cooperation to make some development in this range.
Okay, thank you very much.
I have a question. Oh, sorry.
Sorry, who is?
I'm Ivan. Okay.
Okay. Yes.
I have one question VIGO to Karolina. Well, does VIGO develop 2D sensor matrix for imaging?
No, we produce single detectors on linear or bilinear arrays. At this moment, we do not produce matrix.
So, but it could be happening in the near future, or you are oriented only to single detectors?
Yes, we are considering to produce matrix. At this moment, we produce also quadrant geometry detectors.
Quadrant, okay.
It's only 4 elements, but in the future, it may be more.
Thank you very much.
And you're looking for partners to collaborate on that. Actually, one of the goals that Anna has gone around the world to find you partners who are actually going into a further development of the VIGO future camera systems. One of the future partners is going to be Danny from MAPSI, who has a question for you.
Yeah, hi, Karolina. Thank you for your presentation. I was just curious about if you have found some problem with the selectivity or the narrowness of the filters that you use for the mid-infrared photodetectors.
At this moment, we are not using filters. We are using windows. For medium wavelength, we are using sapphire windows, of course wedged. And for long wavelength detectors, we are using zinc selenide anti-reflection coated windows. But of course, it's not a problem to use specific filters for detectors.
And could you include some other filters like external or like, for example, some that we could manufacture or something like that?
We can provide filters made by us, or we can also mount filters provided by customers.
Okay, thank you. Thank you.
Okay, more questions, comments for Karolina? Okay, so if not, I think we can move ahead in the program. And the next speaker is Adnan Quazi from Hamamatsu Photonics.
Thank you so much, Anna. Let me share my screen. Can you all see this?
Yes, very well. Okay.
So let me then start by introducing myself. So I'm Adnan Quazi with Hamamatsu Photonics. I've been a sales engineer at the UK office for coming up to 6 years now. Also, it's worth me noting that in the last 2 years, I've been the project coordinator for our marketing and market investigation strategic analysis for Europe. So I'm in a good situation to be able to, at a European level, see what kind of interesting technologies are being adopted by different parts of the gas sensing applications. So it is a real pleasure to be joining you today. Where I would really like to focus my presentation on, because some of you may know that Hamamatsu is really diverse in the number of different technologies that they offer. And if I would go through everything, even just related to the IR for gas sensing, we would be here for at least 2 hours. So I just want to focus on one today. And this is what we are calling our hidden champion, our multi-stage indium arsenide antimonide detector. And so let me really try to explain why I am calling it a hidden champion. So taking a step back, then of course, all of you will be familiar with this information, but let me go over it anyway, why you would want to even measure in the mid-infrared anyway. And so of course, when you are using other wavelength ranges, for example, the telecom range, and let me just get up a laser pointer, the telecom range, then you are looking not at the transition lines of different molecules in terms of their absorption, but the harmonics of them. So the actual energy absorbed by those different molecules is not as significant. However, when we move into the mid-infrared, then we are really targeting those transition lines. So when you are using an emitter and a detector in this mid-infrared, your molecules are absorbing more. So you have much higher resolution, much higher sensitivity in the systems that you are creating within this mid-infrared zone. And then alongside that, then one of the other reasons to measure in the mid-infrared related to environmental monitoring that I should mention is temperature sensing as well. And this really, I think, highlighted very simply. Different objects that you want to measure at a standoff will give off, depending on how hot they are, black body radiation. And the cooler the object is, the more in the mid-infrared that it will emit. And then you can see that the actual emission becomes flatter. So you need a higher sensitivity mid-infrared device, but also one that has significantly low noise to be able to actually capture the characteristics of this flatter curve. And this is where I think our multi-stage indium arsenide antimonide detector is really shining. Because of the composition of the material, we can make it have sensitivity from around 2.5 microns all the way up to 10 microns and 12 microns now, even further. And so when we look at our graph of the different kinds of technologies that exist, so I should note that Hamamatsu used to manufacture different technologies as well, MCTs and PBS detectors. And oftentimes we talk about D-star when we're comparing the sensitivity of these different detectors. And now one of the multi-stage indium arsenide antimonide detectors that we have, it only sits here in the green. It looks like it is very low sensitivity or very low D-star when you compare it to something like a PBS or an MCT cool detector. So it seems like it's not really worth looking at because it's got such a low D-star. However, let me go into a little bit more detail about what D-star means. So D-star is proportional, inversely proportional to the amount of the noise equivalent power, the amount of power that you need to input into a detector to make it equal to the total noise produced just by the detector itself. But one thing to note is that it doesn't give you a measure of the parasitic capacitance around the whole system. When you're building all of the electronics around it, it doesn't take into consideration that. And this is something that is particularly important when you're looking at the detector. Because when I talk about multi-stage, it means that the actual characteristics of our detector is quite different. When you would zoom in on the surface of this detector, you will see that it is many individual photodiodes in series with one another. And this has some really strong impacts when it comes to the characteristics of this device. One example is that the actual voltage output, for example, say, you had a photodiode and you increase the active area by 5 times. You'll still get the same amount of voltage from the device. However, with our multi-stage device, the voltage increases proportionately to the amount of current, the amount of photodiodes in series. And then here we have a really cool thing. When we talk about shunt resistance, again, if you had a photodiode and you increase the active area of that to try and collect more light, then the shunt resistance goes down proportionately. However, for our devices, it stacks the larger the active area becomes. And this is really powerful, shunt resistance increasing very, very highly. And the reason is that when we have a high shunt resistance, we can create the back electronics to apply very significant amounts of gain. 100 million, 10 to the 9, 10 to the 11. Sometimes we've seen even 10 to the 12 our customers are applying in terms of gain to these detectors. And the reason they can do that is because the shunt resistance is high, it suppresses the noise down, keeps it low, so you can still get a good signal to noise ratio. And this is where I really, this detector shines. So even when we have the detector with its electronics, it can measure the temperature of the soldering iron. Even if I wave my hand in front of the detector, it is sensitive enough to actually detect the black body radiation from my hand. I thought that was really cool when I saw that. So in a short summary of this detector, then it's the multi-stage structure that gives this detector so much higher shunt resistance, and that large shunt resistance means that you can get really high gain to this detector. So much so that we have even examples of 10 to the 12 level gain. And that high shunt resistance means that the noise is not amplified as much, so you have more headroom to do that. And now, if you would compare this multi-stage detector to some of the detectors that we have discontinued, our PBS and MCT, then you are getting, in circumstances, 2 to 3 orders of magnitude greater signal to noise ratio than our monolithic INAS and PBS detectors. So this, I think, will open up some very interesting conversations for cost-effective, high-sensitivity gas sensing applications. Thank you very much.
Okay, thank you very much. A great presentation. So, okay, what do you think? What are the challenges that you? Okay, I see Lars have a question. Just first of all, the question. No, so what are the challenges that these companies that are here in this meeting could help you with?
So, I think the real challenges that we're facing at the moment. So, what we've come to is that we've been able to invest significant amounts of money to get the orders of magnitude, the pricing to come down. So we can offer mid-infrared detectors that cost a few euros each at the high quantity. But what we really need is the system integrators, the ones, well, because we're Hamamatsu, we're talking to so many different companies already, but they may be producing systems, but not necessarily systems related to gas sensing or have gas sensing understanding or know-how of how to actually make a spectroscopic system. So where we'd really need help is for collaborators with us to be able to take those technologies and develop a gas sensing related system, like a sub-module that could go into different applications. I think that's where we really need help.
Okay, good, clear. Lars, do you have a question, right?
Yeah, thanks. Very interesting talk. I have a question. Could you compare the temperature requirements for MCT and the antimonite detector? So the MCT has to be cooled, and did I see it right? You don't have to cool the this detector?
Yeah. So for particular MCTs, then to get the really high D star levels, then they need to be thermoelectrically cooled or liquid nitrogen cooled, sure. However, I mean, VIGO is also doing this in terms of getting 10 to the 9 D star with uncooled detectors. But we're able to do that now with uncooled detectors. Okay. Of course, MCTs will, if you really want very, very high sensitive, high D star and very high speeds, then MCTs will still win. But this is in terms of a detector that offers very cost-effective, but still relatively strong sensitivity in the mid-infrared, then this is a interesting technology to be able to facilitate that.
Okay,
thanks.
Maybe it's a good moment now to ask to Yoshiaki from Sumitomo Electric to introduce what are you looking for in this meeting and what are your activities in the environmental field?
Hello. Thank you for introducing. Actually, we are also manufacturer and developer of compound semiconductor-based sensors and light source QCL, like the similar to nanoplus or Hamamatsu or APS, but we don't manufacture actually the single point detectors. So just I'm studying the technologies from the Hamamatsu presentation, and also thank you for Hamamatsu. They are of course one of our semiconductor wafer materials. Okay, that's all.
Okay, so yes. Okay, thank you.
Anna, then I would also like to mention just quickly then. So Ian McKenzie, also you mentioned that you were interested in different kinds of lasers for space applications. It's worth me noting as well then that we've had a lot of experience in terms of putting our sensors out into space. I think 2 or 3 detection systems on the International Space Station are facilitated with our detectors. So I think we have the capabilities to even test maybe our QCLs for space-related applications, and maybe we can start a dialogue there as well.
Do you already have a supply chain for this? Do you have partners that are helping you qualify your detectors for space applications?
No, so we don't have the know-how in-house on doing it, but we have the experience to do so. So we're still looking for partners to qualify, but we still have some experience with working within the space industry.
And the examples that you have of applications, is it for trace gas monitoring?
So currently I'm speaking to a number of companies that are specifically related to trace gas monitoring within the UK for space applications. Yes.
Okay.
So it may be the case that we're actually in touch with the same people.
No, I'd be very interested to talk to you further and to introduce you to those people at ESA that are working more closely on those applications.
Sure, great.
So yeah, please make contact and let's discuss what we can do together.
Brilliant. Thank you very much, Ian.
Every 2 years, we have a meeting inside the European Space Agency, normally called Photonics for New Space, in which we try to bring technologies who have not yet been qualified for a space application in contact with the let's call it the primes and companies who have tradition in space to see how we can validate new technologies. And in the last meeting, we talk a lot about photonic integrated circuits. And in the next one, we really definitely want to go into the mid-infrared part.
Okay.
So hereby it's going to be next year in October, depending
September,
depending on how the whole situation, but I think by next year we'll be fine. We'll be fantastic, and we'll see each other in Northvik because it's going to be a great meeting.
Thank you, Jose, for plugging that.
Back to Anna.
Okay, so there are more comments or questions? Okay, then let's go ahead with the program. So next speaker is Peter Totrum from NNI. So Peter, if you want to share your screen.
Yes, I'll do that. Hello, everybody. I'm Peter Totrup. I'm from NLIR Copenhagen. We are a small SME spun out of the Technical University in Copenhagen some years back. We are doing mid-infrared sensors, spectrometers and detectors, and also spectrophotometers now. So for this meeting, I would like to give the raison. Something is wrong here. I can't change pages. Sorry about that. Let's go back. Can you still see my screen, or?
No, we see a white screen.
Yep. I don't know what went wrong here.
NLIR is one of very interesting company. You guys should be ready to see something very special. When it comes to the mid-infrared, I'm quite amazed what Peter is putting together. I think right now you press escape because possibly you can just something on the top of the screen.
Yeah, I don't know what's wrong here. So sorry about that, guys.
Just white screen for calibration.
Yeah.
So it comes up with an error message. I don't know what's going on. So I'll try to click on this and see what's going on here and open it.
Why don't we do the following? Why don't we go to the next speaker, and then we no, it's going to be solved. I have high hopes because now we have a black calibration screen.
Yeah, I don't know what's wrong here. Sorry, guys.
Anyway, if anybody's looking for black coatings, you have great technology in Epic from Sorry Nanosystems, so great company. I think A is coming. You share it again, it's going to work. I have my hopes and my fingers crossed here. Let's try again, Peter.
I'll try again.
Yes.
No, it won't show my my screen. So something is wrong with the.
We are going to solve it. And we were talking a lot before about calibration to enter the space market. So I made a very good friend when I went to Barcelona last time. I met a company called smartHAPS, which is very well known in the European Space Agency business. And I want them to be the entry point for all of us into the space market. César, muchas gracias. Thank you very much for being with us this beautiful afternoon here in the Netherlands. I'm sure it's also beautiful in Spain. I want everyone to understand what's a hub, what's a smart hub, and how to bring photonics into a smart hub for space application. César, the floor and the attention of everyone is yours.
Thank you, Jose. So first of all, thank you very much to Jose and Anna and Elena for the organization of the meeting and for giving us the opportunity to present our company here. And let's try to skip that. So the name of the company is smartHAPS. I'm César Martínez and I'm the CEO. And we are now, as Jose said, part of the Business Incubation Center of DISA in Madrid. So this is the point of view of the end user, although we are not really the end user of the information gathered for the sensor, but in real, we are the end user of your technologies. So the problem is the concentration of people in big cities, because we have more than 500 cities in the world with 1 million people or more. So it's going to be a problem in the future, and it's a problem right now. So due to this concentration of people, cities generate a lot of pollution, a lot of greenhouse gases. There are a lot of traffic accidents, natural disaster, and everything. So due to this situation, the government, local government, regional government need a lot of information to take decisions. So they have to track a highly dynamic process in real time, and they have to detect a small size changes in the parameters. So let me introduce you the HAPS concept. HAPS stands for High Altitude Pseudo-Satellites, or sometimes High Altitude Platform Systems, and they are aerial vehicles able to emulate satellites. They cover a specific area of interest, and they have enough endurance to provide long-term services. So this kind of platform are operating from the stratosphere in a typical altitude of 20 kilometers. And that region is used because there are minimum wind speeds at this altitude. They are powered by solar energy, and they can operate from a fixed position, and they can be recovered for maintenance and upgrade. So this kind of platform can provide complementary services to satellites. There are two types. One of them is the LTA, the airship type, and the other one is the STA. So there are really aircrafts powered by solar energy in both concepts. So this kind of platforms can cover the demand of cities and other applications, not only cities. So they can cover urban areas. They have a lot of persistence. They can cover the area during typically months, and they have a very high spatial resolution. So our concept is based in the use of a small payload, and this is a message for you as instrument developers, because the smaller the best. We have to save mass for the platform. So we are looking for a small payload with a very low demanding instrument in terms of power consumption, in terms of mass,
and dimensions. And our approach is based in the ones used in nanosats with a very small payloads. And at the end, we can get a smaller platform for the whole operation. So that's all. We really, as I told you before, we are not the end user of the information, because our intention is to provide services to final users. Could be regional government, but there's a lot of application related with security. In general, any application related with remote sensing. But we are interested, for example, in environmental control, and also in agriculture, and also in maritime domain surveillance. But there are a lot of applications related with defense, with security, and everything. So we are really happy to know you as instrument developers, and we can keep the contact for the future. Thank you very much.
I'm always fascinated by space technology, as you guys know, and this gives me goosebumps. The opportunity for us to interact with you and to help each other developing photonics for this application is a unique opportunity. You were talking about a typical value of 20 kilometers. Is that changes for certain applications? That's the standard distance?
This is, let's say, the standard altitude, but it's only due to the winds, the atmospheric condition. So it could change from, let's say, we should operate for a high level, very high from the commercial aircraft, commercial flights, be something between, let's say, 18 kilometers to 24, 25.
You saw before in the program, the presentation from Chromacity that has these ultra-fast lasers that can actually put next to a telescope and actually determine very accurately the gas sensing. Is there any request? And you're going to tell me as light and as small as possible, but is there any standard request on payloads?
We are looking for payloads with a mass around 15 kilos and a maximum power consumption of below 100 watts. I know that most of the instrument we use in the small site can meet that requirements. But at the end, it depends on the application. As I told you before, we are now talking with some end users who's interested in monitoring the environment or monitoring the agricultural. So depending on the application, but the idea is to keep the platform in a fixed position. But we can also move the platform once in flight to reach other areas. And one of the really power characteristics is that we can recover the platform for maintenance and upgrade and everything. And then we can launch again, even from another area. But the idea is to fill a gap between the drones, the aerial drones, and the satellites.
One more question before I ask Thierry, because Thierry from Lambda X is like our key company spectrometers for space applications. But before that, you said that it's all solar powered, of course. We cannot plug it there. Any request on power consumption?
I told you something below 100 watts.
Below 100 watts, that's your request. Okay.
Right.
Thierry, you have been in EPIC for a while. Every time I go to the space agency, they say, we know Lambda X very well. What do you think of what we just saw? Any kind of collaboration that we can enable here with smartHAPS? And then I will give the word to Ivan. I already saw you.
Yes, thank you for giving me the stage again. Actually, yes, Lambda X has 25 years experience in developing optical system for space. And actually, I wanted to mention to smartHAPS that we have developed and we are developing a payload for HAPS systems, which should meet the requirements of light, weight. We do that for Earth observation purposes at this moment, but maybe we could collaborate or think of some partnership for gas detection, which would be new for us. So we could help you to combine your optical or your detection to a payload that would meet all the requirement to do fine measurement at 20 kilometers from the Earth.
It's an easy partnership here. Let's make it more complicated. Ivan, what can you do for smartHAPS?
Okay, thank you very much, César, for the nice presentations. Okay, I have one question, but before I would like to say that personally I have experience for measurements at high altitude platforms like stratospheric aircraft, Russian aircraft, which is flown at 20 kilometers for a study of the stratosphere, ozone, and other minor compounds. So here we can find maybe some collaboration, but my question was, what is the duration of the flight? How many hours can stay at given altitude or to move?
The idea is to provide services during several months. That's the objective. We are not talking about hours or weeks, but the idea is something around 3-4 months of continuous operation.
Okay, I see. Thank you very much.
And really the challenge is related with the excursion in temperature, because the situation is quite similar to those in space, but the difference is when you are operating in space, the eclipse time is only 30 minutes. In that case, the challenge is that we have to survive without direct solar energy during, let's say, 9 hours, 10 hours even.
But to monitor the atmosphere on the ground, some windows should be necessary in order to observe the targets. So do you consider to mount some windows on the platform? Or all things have to mount it outside?
I don't understand. What do you say?
Let's say if
windows,
one telescope, how this telescope will be installed on the platform, externally or internally? If it's internally, it means that some windows should be provided.
Right.
Okay.
Right. The idea is to install internally and to provide some windows to
okay, thank you very much. Okay, thank you very much.
Okay, and I will say Thierry from Lambda X had another question. You are mute. You are mute.
Oh, sorry. So still mute? No, unmute.
No, it's okay.
Well, in your slide, you introduced two concepts of HAPS aircrafts, or we may call them so, the lighter than air versus the heavier than air concepts. So could you shortly introduce the pros and cons of the two concepts and position your own proposal in between those two?
Our intention is to develop the airship, I mean the LTA, the lighter than air. So the idea is to develop this kind of vehicle to provide services from the stratosphere for end users.
And why this one? What is the advantage of this lighter than air versus the heavier than air, which could find some ways to get long flights and to find the power to stay over there for a while?
The advantage from our point of view is that the endurance, because flights with an aircraft could last, let's say, in the order of weeks, 3-4 weeks. And the idea is to provide services during months. And in addition, we can get more sun energy because we have a big surface. So we can get more power, because power is an issue, is the key point here.
Okay, thanks.
Okay, thank you very much. Yes, we could talk about this for hours, right? This is okay. So maybe this is a good moment to introduce to you one of the companies that we have here. So Iwan from IQE, are you here? Okay, could you introduce? Yes, hello. How are you doing? Everything fine?
Very good.
Okay, would you like to introduce what is IQE doing, and well, what are what are you doing in the field of environmental?
Yes, okay. Thank you, Anna. IQE is a compound semiconductor epitaxial wafer manufacturer. That's all we do. We have interests in the mid-IR epi wafer manufacture. We are actually involved in in a large pilot line project with some partners here, the MIRFAB project, EPIC of course included, nanoplus, and ALP, and I'm looking around everywhere, CSEM.
Alpha you mean?
And VIGO. And so there are a number of companies already involved in a very big Horizon 2020 pilot line project. And so our interest is in trying to expand our portfolio in MIR capabilities. And we recently developed quantum cascade lasers by MOCVD in manufacture in Europe. But we also are looking at expanding our portfolio in antimonide detection and emitters as well. So that's IQE's capability. If anyone would like to get further information, then please contact me.
Okay, thank you very much. And also taking advantage that you mentioned the pilot line MIRFAB, we have here another partner of MIRFAB, Stefano from CSEM.
Yes.
Hello, Stefano.
Hello, everyone.
How are you doing?
I'm fine, thanks.
Would you like now to introduce what is CSEM doing in the field of environment?
All right, so yes, CSEM, we are a private RTO in Switzerland, as some of you might know, with the mission to develop technology and transfer it to the industrial sector. So we have quite a lot of activities actually in environmental monitoring. Especially myself, I've been involved in a few European projects for monitoring contaminants in water and also for particle monitoring. So we recently just started a project actually for measuring microplastic. So it was interesting to hear the question from Lars, I think it was, from nanoplus. I will contact you after the meeting because we might have some interesting technologies for measuring nano and microplastics in water. So yeah, for me it was very interesting to hear about the new applications. Also, we are of course interested also in novel components for environmental monitoring. And so today was a great opportunity to see what's going on also in the field of new light sources and detectors for these applications.
Stefano, CSEM has been instrumental for us to bring many technologies validated to the space and to the harsh environment markets. I honestly believe that between CSEM and smartHAPS, we have all the ingredients to make sure that we build instruments directly to be deployed in César's beautiful aircrafts. So I think here there's obviously an introduction. I really want the two of you to have a discussion offline because you should be the entry point to bring more technologies to this beautiful smart hub that was presented by César. Thank you so much for being with us, César. It was such a great presentation. I told you when we spoke together in Barcelona that it was really a good community, this one epic. So thank you for experiencing it. And let's go to the final speaker today. Let's try your luck with the great detectors that are made in Copenhagen in the mid-infrared. Let's go to Peter. Peter, we really want to hear from you. We really want to see what we can do together. The floor and the attention of everyone and my cross fingers are for Copenhagen. It seems to be working.
So you can see it, or?
Yes, go presentation mode and you will make me extremely happy.
Yeah, me too. So there we go.
Yes. Come on, the floor is yours.
So again, small and SME from Copenhagen out of DTU. So we make spectrometers, spectrophotometers, and detectors. So what is the raison d'etre, the reason for this? I mean, in mid-infrared, there you have these primary molecular vibrations when you do spectroscopy. In the visual, in the near infrared, you have silicon as a detective material. So what we do is we combine those two. So we take the best of both worlds. So we take the mid-infrared light, we up-convert it to be a visual light. I mean, 700 to 1000 nanometer light. And then we use the silicon detectors. So this is our claim to climb. So, and we make these single wavelength detectors. We say they are probably the best detectors, mid-infrared detectors in the world, uncooled. We go up to 10 gigahertz and we go down all the way down to NEPs of a few fem towards root square hertz. So we have an unprecedented performance on the electric side because we use the silicon devices, and we have this very low sensitivity. And on the spectrometers, we also have a very unique combination of speed, sensitivity, resolution. So we have just made launched the fiber spectrometer for that range. That actually, when a lot of near-infrared companies stop around 2, 2.5, we start from 2 to 5 with this one. And here are some of the things we have measured with our fiber spectrometer. We have to the left, this is for plastic reflective coating, reflective measurements. We have seen the differences between black plastic. We have some carbohydrate gas monitoring. Here's methane. We have seen methane. Some of the detectors we can use, you can go down to nanoseconds, but here we do it a little slower. And we also have done some together with a Dutch company, a university, did some food storage gas analysis with our spectrometer. And right now we're also in a project, Eureka project called MIRDIAL, where we do a mid-infrared differential absorption LIDAR, where we are doing a very cost-effective tunable light source, and then we are using our detectors for high sensitivity. And we have this group here, CML, the Danish National Meteorology, and HCP from Taiwan, and then us come in this company, in this project. And what else have we done? It's with environmental. We have also done CO2 measurements in ship funnels, and we have also shown the technology together with DLR in Germany by planes using our technology, where they showed that they could go from 7 kilometers to 10 kilometers by using our technology up against other technologies. And what can we do for each other? Yeah, we're always looking for new applications. So if you see anything that can benefit from having our sensors, contact us. And of course, partners, we are OEM strategy also, and we're looking for integrators and system builders to use our high-end products. So thank you. So that was my...
Okay, thank you very much, Peter. Very nice presentation. Okay, so then what will be because you already say what are you looking for, what will be the perfect companies in this meeting room to collaborate with?
I mean, the integrators are the people we are mostly looking for now, because we have almost consolidated our technology to the first level. So we are looking for people who can integrate it into solutions in this.
Okay, thank you. Comments or questions from Peter? For Peter? Okay, if not, maybe I would like to introduce to you one of the system integrators that didn't speak today, I think, Kerr from Avantes. Hello, how are you doing?
Hello, Anna, thank you. I'm doing fine.
Okay, will it be a good moment for you to introduce what is Avantes and what are your interests in the field of environmental monitoring?
Yeah, so I think I'm not really a system integrator on that part. We as Avantes make spectrometers, complete modules, and one of the fields we are active in is the environmental field, and mostly in DOAS, so NOx, SOx detection. And also, like a lot of companies here, we are seeking actually for system integrators who can incorporate our products into a total solution. So I think that's one of the goals everybody is seeking here, or at least most of us. And basically why I'm joining is tapping in what is happening in the environmental field, what new things are there, are things shifting to the MIR or still looking in the visible and in the infrared to detect things. And very importantly, to get a grip of what is happening in the photonic field, what companies are playing there, what are they offering. So that's one of the main reasons I'm looking and listening to you guys here and finding out what you are doing, so that when the point comes there, that I can be able to say, aha, I have to contact these guys once to see if a collaboration is in place. So at the moment, not directly, but I hope that if we keep talking to each other, that we will find each other.
Okay, perfect. And we got a few questions. So Bill Choi from nanoLambda, do you have a question?
Yes, I have a question to NLIR. You just mentioned that you do actual measurement using the silicon and for the midwave IR, and you mentioned that some kind of up conversion. Can you tell what kind of material do you use for that up conversion?
Yeah, actually, we use the same materials that everyone else is using for down conversion when they do lasers in that field. So it's the lithium niobate and these kind of materials.
Okay, thank you very much.
But I mean, the thing we do differently is that internally in our devices we have a very powerful laser field, above 100 watts standing laser field. I mean, this is a laser field we don't need and to use for anything else but up conversion. So that's one of the technologies we have invented.
Okay, and I saw we have also a question from Ivan. Yes, I am right? No? Okay, so that was done. Okay, perfect. So there are more questions for Avantes, for NAR, or no? If not, Jose?
Yes, what a great meeting. 2.5 hours, 2 hours and 39 minutes. So sorry for these 9 minutes, and I will buy you a beer for that. It was a really, really great meeting. I took a lot of notes. I learned a lot. We brought together system integrators. We brought companies in the IoT. We brought companies in the optics, in the lasers, and 2.5 hours to find things to do together. That's what I do for a living, and I love it. While I was chatting to all of you in WhatsApp and in the chat, at the same time, I took notes. I love taking notes. That's my sickness. I was taking notes on my wedding, I think. And I took a lot of notes today. Actually, for me, I really see that the biggest market trend that was between all of you was about a smart photonic sensor that can be suitable for the IoT. And the challenge, was it a cost? Not really. And that for me is the learning point. The nanoplus had very strong comments there. The volume production really, really drives the cost down, and they have proved that. They have proved that with a couple of their application fields. And for me, that was the biggest learning point of this meeting. There were main requirements being shared by Ineso on the IoT demands of VOC plus gas sensing. And I think Ineso there has been quite of the good things to have you at the meeting, because we're going to have many people wanting to be introduced to your technical people for collaborations. We were talking also about other suitable solutions for example, the MEMS-based sensors of SENSIRION, the near-infrared spectrometers from Xenorics, also driving the cost down to the current demands of IoT. But there, I would like to highlight again the comment from nanoplus. Every technology is stopped for volume production because we are based on semiconductor manufacturing, which is by definition low cost in the volume. We talk about components. We talk a lot about QCLs because this is Europe, because we love QCLs, because we have the best QCLs in the world. And there we really saw, I was very, very happy with the comments from Al Placer about the current solutions for the space market and how the environmental monitoring is really, really growing. And this is because we really can address the nastiest wavelengths there are between 3 to 12 micrometer wavelengths, and that's really a huge market. On that, I also love the ultra-fast laser presentation from Chromacity, especially when we're talking about the OPOs and the tunability between 1.4 and 4 micrometers. And they were talking about that, really the measurement of different species in one sweep. And I think there, we do have a key application field, I think, especially in the space market. We also talk about the detectors. I love the presentation from VIGO, and I love the presentation from Hamamatsu. I think they call it the hidden king, the hidden champion. I think this indium antimonide detector, you are really in the business, especially when it came for the photodiode array. And I was very, very, very impressed with these trends. There's a trend for validation and testing of the sensors on different markets, especially validation for the space. And also a trend on the hyperspectral. We mentioned that we didn't have a presentation on hyperspectral this time, and this is because we had a whole meeting on hyperspectral. But Lambda X really, really saw that there is an opportunity for Earth observation, and that was when I think the biggest opportunity, the low-hanging fruit of this meeting is the collaboration with the smartHAPS. So basically, they already are very well positioned at the European Space Agency and one of the incubator startups, and they have a fantastic CEO who is also really friendly. They can be our entry point to actually do Earth observation and remote environmental monitoring with a beautiful ship. I mean, you got to see that. It's just beautiful. And then the integrators, I was very happy with the presentation from Tenevia, seeing as the growing market of water quality monitoring. Other than that, I think the most important thing here is we all learn, but it was not a meeting for learning, it was a meeting for business. So now the ball is in your court. Please follow up with the introductions here. Please make sure you do business because you are epic and you doing business is what pays my life. Thank you very much. Until the next time, keep being epic. See you. Bye-bye.
Bye-bye.
Thank you, Jose and Anna.
Everyone, bye. Thanks.
Bye. Thanks a lot. Thanks for a great meeting.
Bye.
Next time, I hope we have a beer.
Yes. Well, I drink coffee only, but I'll drink a lot of coffee. Well, the mug is really, truly, honestly great.
I love that mug.
It's just incredible. They even copied the color of the tie. It's just, oh my God. It's just when I saw it, I couldn't believe it. It's just me, and my wife said, "Yeah, it's you. That you look like that."
Thank you for having us today.
Thanks a lot.
Bye-bye. Thank you, Peter. Great presentation.